So, before jumping into additive manufacturing, we would like to remind that there is a big concern about carbon dioxide in the current situation of the planet. If we look at it, the two main domains creating carbon dioxide is transportation and electricity production. If we focus in French market, tire is working for cars and trucks and have a big impact as 93% of carbon dioxide. In Michelin, we provide not only tires, but also solutions to move forward with cost reduction and sustainability.
So in order to tackle this problem, we want to decrease the CO2 consumption globally and worldwide. And to do so, the main action is to decrease the energy dissipation. That means the energy used to move a vehicle, all right? And from the tire point of view, the main goal is to decrease the rolling resistance. But you have to know that there is a trade-off between the rolling resistance and the weight performances. For the rolling resistance, we need shallow treads, and for the weight performances, we need deeper treads. So two researchers from Michelin got this idea a few years ago, is what if we could design a tire with multiple shallow treads put and stacked on the top of each other. By this way, we can have all the throughout of the tire, we can have the rolling resistance and also the weight performances. And this technology is called the auto-regenerating tires. And we'll see the example in the video just now.
The X-Line Energy Truck Tire Line features complex tread patterns that self-regenerate mile after mile and provide the necessary grip throughout the tire's lifespan and in all conditions. In passenger car and light truck tires, the cross-climate tire's V-shaped tread, combined with new self-locking 3D sipes, enhances vehicle traction in summer and winter alike. The Michelin Premier AS and LTX tires have a self-regenerating tread. Thanks to complex 3D sipes, grooves appear as the tire wears, and water-draining grooves become wider with time. Even when the tire rubber wears down, the level of grip in wet and snow conditions remains high.
And what's really interesting in this new technology is that not only it enables us to increase the performances of the rolling resistance, but also other performances like the dry, the wet, the braking, the noise, and so on. So, as you already understood, we use 3D sipes. That means we use a new way of manufacturing the sipes of the tires in order to have 3D sculpture on the tire and to reach these performances. Let's see how it works.
Michelin leverages its technological leadership in a continuous drive to improve its tires' performances. These tire performances depend to a large extent on the tire's tread design. The tread is obtained by forming the rubber compound in a metal curing mold. A curing mold for car or truck tires can contain thousands of steel sipes arranged in hundreds of different patterns. A winter tire, for example, can have up to 3,000 sipes and over 200 different siping designs. This constant effort to improve performances and especially wet and snow traction throughout the tire's life has led designers to define increasingly sophisticated sipe shapes. Metal additive manufacturing, more commonly known as metal 3D printing, can produce these very complex sipes. In additive manufacturing, we start by modeling the part designed. A 3D digital data file controls the operation. A beam of concentrated energy, such as a laser or electron beam, is used to melt a metal powder and generate the object. The material is laid down layer by layer to create the part in just a few hours.
Okay, so that was the explanation, and as you can understand, we wanted to keep it secret at the beginning because it was a breakthrough technology for us, and the way we were doing it was quite confidential. But by the way, with the journey we had on this 3D printing adventure, we think that is not an easy peasy way. And even if it's a really game changer for us, and we think for humanity globally, we think that by sharing our experiences all together is the better way to move forward faster and better altogether. So let's see what happened behind the scene.
Let's have a look to our journey. In the early 2000s, we work on additive manufacturing. If I say Michelin, what are going in your mind? For sure, a tire. But Michelin is not only about tires. Even if a tire is hundreds of materials and tens of processes to manufacture it, we also worked on around and beyond the tire with a solution for customers, eco-friendly solution for B2B, and development of material eco-friendly.
So there was a lot of products, process, and so on in the Michelin planet. And the first reaction when we saw in the early 2000s the 3D printing arrived on the planet, we say, okay, great. Maybe it's a new invention. That means we won't be able to have added value in terms of commercial or industrial products. Or is it really a brand new technology? And so it will be an innovation for us. So that was the key question. And as we often do in Michelin, we try to look closer to this technology, and we dig into it on the mold department. Let's see the journey with Guillaume.
Our first step in additive was discovering the process and finding new applications where additive manufacturing add value. So this was in 2006, and we go like that in this journey. Thanks to a lot of improvement in machine and process, like dimension of the machines and laser power and so on, we improved the capability of the process, but we also faces some threats like powder management that was new, and due to granulometry and composition, we had to take new measures like PPE and a lot of things that we discovered at this moment. At 2009, we were at a step of proof of concept on SIPes for molds. So we identified our first use case where additive could have a value for Michelin.
So what was important is that at this stage, we were really convinced that the 3D printing can be an advantage for the final product, for the tire. But as an industrial, I would say, maturity, we were far away from the other process. And maybe it's very important that to say that we wanted to focus on the SIPes, the 3D SIPes. And here you can see the different characteristics that we have on the SIPes. So it's a very complex 3D geometry. We have high mechanical stress to endure. We also have very strength mechanical properties on the thickness, 0.2 millimeters until 5 millimeters, all right? So this is a real nightmare for 3D printing today and by the time also. So let's see what has been done to tackle the challenge.
At this moment, mold added value was known with the lamels, but we had to work on certification, validation, and robustness. We also have to treat the limits by building confined area to protect people, changing powder we use to improve material and reduce the exposure of people to some materials which were hazardous. And we worked on confined area to keep all this process under control and protecting people. Even if the process was not really robust, as a bet, we deploy a big quantity of machine. The overall equipment effectiveness was around 50%, but we were convinced that there was value for the final product, for the tire. And this led to the first serial production of SIPes for Europe with the launch of the cross-climate tire line, and in the US for the premier all-season tire line. So this was our first success after 8 years of up and down adventure with human aspect and technical up and downs also.
So even if we have made a lot of work on the process, we are very far away from the optimum system compared with the turning, milling, and so on, the other processes that we have on the workshop, all right? So the group wanted to move forward on these brand new tires and wanted to deploy it globally on the B2C side, B2B, and so on. So we had no other choice but to find solutions in order to improve the industrial performance. So let's go on the second journey to see what has been done in the last 10 years.
So once the use case was validated with SIPes for several tire molds, Michelin was needing to be leader on additive for mold production. There was no solution in the market that was ready to fit with our needs. So Michelin decided to create AddUp, a joint venture with FIV, to reach the targets, industrial targets that we need. For AddUp, it was a big challenge because there was technical needs, but also cost, performance, and all the process needed to be under control. So AddUp designed a machine with strong relationship with our need. And in 2019, we lead the benchmark because it was money time for our second phase of deployment with new machine and last updated performance. So we led a benchmark with other brands in the market, and we confirmed that for our use case, AddUp was the best machine in terms of quality and productivity. The production time were very low. We reduced it by 5 or 6. And we improve the overall effectiveness of the machine from 50%, as I said before, up to 85% now. So this was the reason why we decided to deploy these machines. Now, these machines permit us to manufacture SIPes as an industrial way. We printed more than 1 million parts, and AddUp supports us in terms of process parameters optimization, but also users training and maintenance on all our sites in France and in the US. So now I will let the hand to Julien to complete it with AddUp.
So hello everybody. As you see, in 2016 we had a great challenge from Michelin when AddUp was created to reach those very challenging quality and production time. And we developed the FormUp 350. First of all, I want to say that behind AddUp there is two shareholders that are Michelin and FIV, and they are really industrial. They have each more than 200 years of histories, and they know how to talk to industry. So, and I think that's the key of how we decided to create AddUp and develop these machines. So the AddUp machine, and maybe a few words on that, and why it was a success for Michelin, and why we reached those challenging criteria. So I think the first things we were looking for was the surface finishing quality, and we do that thanks to a recoating roller system and also the use of fine powder. I think the second thing was the productivity that we reached through like a 4 laser system going all over the platform. The third was quality insurance that we reached through a suite of monitoring solution. And I think the last one was also safety and powder management, where we developed with the German supplier ASO a system managing this. So, but the machine was not the only thing that make us through this success. Also, the way we have support and help Michelin in the training, in the part qualification, in the co-design, in also upgrade of the machine afterwards, and that's basically the DNA of AddUp, to talk to industrial companies and to help them to forget machining and goes with 3D and get the best of the 3D. And I think that's also the goal for everybody here. If we have a lot of industrial companies using 3D as they use machining today, will be a success for all of us here in the room. So this success we had with Michelin, we duplicate it with other industry. So right now we have also serial production in the medical area with a company like Stryker. In the tooling and molding, we saw Michelin. We have other examples also in defense and aerospace, like with Thales, for example, with Dassault, and so. All over again, Michelin was the case of Michelin make AddUp born, and right now I think the goal for all of us is to have more and more industrial production in series of big industrial groups, and I think this will help to win the battle of 3D printing dominance that was discussed this morning. So, and thank you to Michelin and to Olivier and Guillaume for being here with us. And I think I will give them the microphone again.
All right. So now let's see what happens in the plant. So this is the last movie, so to show you the current situation. Okay, so as a conclusion, we have maybe 5 key points that we wanted to share about this wonderful journey that we have during the last 15, 20 years ago. So the first one, and I think it answers to some questions that we got this morning. The first one is that for us, what is really important is to be focused on the product first. And when I say the product, it's the final product that we sell to the customers, and that may be the intermediate products that you can have internally for the production. Because when we are focused on the product, what we want to reach is the added value that we can have thanks to the 3D printing. If it's just for economical reasons, for optimization, for us, it's not the goal. We want to push breakthrough technologies on the market thanks to the 3D printing. It was the example with the 3D Sipes, but we are working today on new solutions on the tire side, but also on other markets, because we're working on the mobility globally, also on the medical side and so on, and we want to use the 3D printing as a lever to push brand new technologies on the market. The second one is about partnerships. This is really key because, as you have seen at the beginning, we are quite alone. We developed on our garage, I would say, the technologies, the machines, and so on. But you have to deal with many topics. It could be the machine, it could be the powder, it could be the footprint. There is a lot of different area of expertise, and we think that alone we can't work well. So it's really important to find the right partners to build the confidence with these partners and to move forward together. So this is the second key point. The third one is about the techno integration. As you do know, today there is a lot of different machines to manufacture the parts, injection, turning, milling, and so on. And when you put the 3D printing inside this workshop, it's sometimes very difficult to find the right balance between the different processes. And it was the case for us in Michelin, and it's also the case today because we are working on new products. And to find the right percentage of usage between the 3D and the conventional way of manufacturing the parts can be a mess and a nightmare. All right. The fourth one is about the change management. And at the beginning, we underestimate this topic because we thought that there is a lot of innovation on the tire side. So we think that okay, it's huge, so we can move forward. But at the end, we have to change the skills. We have to to train the people. We have to change the way we use the CAD and the CAM tools, and so on and so on. So there is a lot of impacts on the company. So don't misunderstand this point and put it on the project management. And the last one is to be patient and confident, because it takes time to deploy the 3D printing. And if you are not convinced that you have to go in this direction, if the group, the company don't want to go in this direction, it's no way. So you have to be confident and then to be patient. And if you are convinced that you can bring innovation thanks to 3D printing, it works. So on our side, we will continue to find new opportunities, as I said, and we hope you will do the same, and you will work with other customers and so on to move on this direction. And we will be very happy to share your experiences also to move forward together. Thank you.